Students, get ready for chemistry class. Students, are you all ready for the class? Okay, today we are going to continue the same topic. Surface chemistry. So yesterday we have discussed about what is absorption and what is the difference between absorption and adsorption, and what are the characteristics of absorption. Okay, you have seen. And today also we are going to continue the same topic. Okay. Surface chemistry. So under that, we are going to discuss about the types of adsorption today. Okay. Now, what is mean by adsorption? We know, because whenever the adsorbate molecule, okay, it is adsorbed on the surface of a adsorbent. Okay, the two concepts should be very clear. So adsorbent means, so what is adsorbent? Okay, the solid that takes or the material on which can take the material, okay, on which the adsorption is taking place. On which the adsorption taking place. This is called a adsorbent. Okay, adsorbent. So far we discussed about you can take metals like all metals like copper, you can take silver, platinum, palladium, even some colloids. Okay, so it is not a colloids means what? It's not a true solid, it is not a true liquid. So in between the solid state and liquid states, okay, they are existing of a colloidal solution. Okay, so those substance it will be acting as a adsorbent. Even the silica gel, okay, silica gel. So this is also acting as a good adsorbent. Okay, adsorbent. And same way, if you take adsorbate, what is adsorbate? So adsorbate is, okay, the material which is going to be held to the surface of an adsorbent, which is going to be adsorbed. Okay, so adsorbate example, you can take so many gases. Okay, so the gases, if you take helium, neon, okay, helium, neon, and ammonia, even a solution of HCl and NaCl. You can take solution of NaCl and HCl. It will be acting as a good adsorbate. Okay, so what is adsorbate? substance, okay, absorbed on the surface of solid. The surface of solid is nothing but water, adsorbent. Okay, so these two concepts will be very, very clear. So whenever the adsorbent molecule, it is going to be absorbed on the surface of our adsorbent, we will say this type of process is called what? Adsorption. Okay, what is the process name? This is only named as what? Adsorption. Okay, so this is selective adsorption of a adsorbate molecule on the surface of a adsorbent. Okay, so this phenomena we know already. Okay, but today I am going to discuss about the types of adsorption. Okay, the types of adsorption. Types of adsorption. Okay, now the types. Okay, I'm going to give a types of adsorption based on the forces acting, that is between, that is based on forces, okay, that will be acting, forces acting between adsorbent and adsorbates okay, so from that we'll get an idea. So there must be some forces that should be operated between adsorbent and adsorbate, then only we will get water adsorption. Okay, now there are two types of adsorption. Okay, types of adsorption, there are two types of adsorption. So one is physical adsorption. First one is what? Physical adsorption. So we know that the physical adsorption, we can give another name, physisorption, or okay, physisorption or Van der Waals adsorption, like that. Okay, so physical adsorption, we can call it as what? Physisorption or Van der Waals adsorption. And the second type we are going to discuss, the second type is chemical adsorption. Chemical adsorption, or we can say this as chemisorption. This is a chemisorption, or we can call it as activated absorption. Activated adsorption. Okay, activated adsorption. Okay. Now, if you take that, what are the types of adsorption? One is physical adsorption, and the second one is a chemical adsorption. Now, we will see what is physical adsorption, what is chemical adsorption. Okay. Now, if you take a physical adsorption, okay. Now, I'll give you what is physical adsorption. Okay. So, if you are taking the solid surface like this. Okay, solid surface. And whenever in the solid surface, if a molecule, it is going to be adsorbed. So this will be acting as a what? This will be adsorbent. Solid surface acting as a adsorbent. Now the gas molecule, it is going to be absorbed on the surface of a solid. Okay, so this will be acting as what? adsorbates. Adsorbates. Okay. Now, whenever the adsorbate molecule is going to approach the adsorbent molecule, and these two, okay, these two, that is the adsorbate molecule, is going to be attracted towards the adsorbent by using of a weak forces. By using of a weak forces. This is called a weak forces. Okay. Now this adsorbate molecule is going to be adsorbed on the adsorbent by using of this only the weak force of attraction. So this will be a weak force of attraction. That is weak force. Okay. So what is the meaning of weak forces? So there is a force acting between adsorbate and the adsorbent. That force is what? Very, very weak. Okay, you can claim it readily. And what are the weak force of attraction? We have the weak force of attraction. It can be a van der Waals force of attraction. Van der Waals force of attraction, or it can be a dipole interaction, can be a dipole interaction. We know that dipole interaction, that is relating to the charges. Okay. And dispersion forces. Dispersion forces. Okay. This is also relating to the charge. Okay. So in physical absorption, there is existing of a weak force of attraction between adsorbate and the adsorbent. Those weak forces I can categorize into three types. One is, it can be a van der Waals force of attraction, it can be a dipole interaction, or it can be a dispersion force. Anyway, all these are what? Weak force. All these are what? Weak force only. Okay. So whenever if you take a physical absorption, okay, so during the physical absorption, there is no bond is formed between the adsorbate and the adsorbent. There is only the forces acting between these two, and we are getting the absorption. Okay. And during this process, the heat of absorption, if you talk about the heat of absorption, heat of absorption is very low, is less. Okay. And if you take that, it is related to 40 kilojoule per mole only we require. Okay. So the heat of absorption. So what is heat of absorption? So the heat required for the absorption. So during that absorption, we know that whenever the adsorbate molecule is adsorbed on the surface of what? Adsorbent. During that absorption, there must be liberation of a heat. So heat is not liberated as it is. During the formation of a whatever may be the force of attraction, whatever may be the bond, okay, so during the formation of a bond, certain amount of energy that has to be liberated, and that energy only it is converted into heat. Okay, so if you take physical absorption, the heat of absorption is very, very less, that is equal to 40 kilojoule per mole only required. Okay, so this is called a physical absorption. Just you keep it in your mind. So between adsorbate and adsorbent, okay, there must be only weak forces acting between these two. Okay, and if you go with the physical, if you go with the chemical absorption, okay, so so far we know that chemical absorption, how it is possible. If I take a surface like this is a adsorbent, okay, this is a adsorbent. Now the adsorbate molecule, if you take an adsorbate molecule, okay, this is your adsorbate molecule. those adsorbate molecule, okay, forms a bond between adsorbate and adsorbent. This is called a bond. Okay. So during the chemical adsorption between adsorbate and adsorbent, okay, there must be existing of a chemical bond formation. Okay, so we know that whenever the bond is formed, the bond is what, a very strong bond. So during the chemical formation, so what is the force of attraction between these two, adsorbate and the adsorbent? So these two molecules are, okay, so attracting towards each other by using of a what? Bond formation. Okay, bond formation. The bond formed, okay, the bond formed, it is a strong bond because we know that it is a single bond. Consider as a single bond. It is very strong bond. So in physical adsorption, there is a weak force of attraction between the adsorbate and the adsorbent. But during chemical adsorption, there must be existing of a bond between adsorbate and the adsorbent. Okay, this is only a difference. So during a bond formation, we know that the heat of adsorption value. Okay, so it is a strong bond. So heat of adsorption. If you take the heat of adsorption value, that is very high value. So we get 400 kilojoule per mole. 400 kilojoule per mole. This is what physical adsorption and the chemical adsorption. Okay. And what is the example we can give for a physical and a chemical adsorption? So far we will consider the example for a physical adsorption. Okay. So if you take any gases, okay, the adsorption of gases, any gases, that is adsorption of gases on charcoal. We know that charcoal is made up of what? Only carbon. Okay, so adsorption of gases on charcoal. Okay, so it is a good example for a physical adsorption. Okay, and same way, adsorption of hydrogen gas on mica. Okay, these two are the example we will consider as a physical adsorption. Okay, in the same way, if we go with the example for a chemical adsorption, okay, we will consider when we take physical adsorption. Here I mentioned adsorption of gases. Okay, here adsorption of gases. I'm not mentioning of what type of gases. From that you will get the idea. It is not specific. It is not specific. Whatever may be the gases, not specific. Whatever may be the gases, okay, you can take those gases and that should be absorbed on the charcoal, like already helium, neon, oxygen we discussed. Okay, so likewise here also in chemical adsorption of a chemical adsorption, so adsorption of oxygen on tungsten. We know that tungsten is a metal. Okay, and if you take that here, specifically I mentioned oxygen. Only the oxygen gas only absorbed on the tungsten. If you take hydrogen, it won't be absorbed. If you want to absorb hydrogen, we should take adsorption of a hydrogen. That should be on, okay, on nickel only. Okay, so if you take that here, there is a difference. So physical adsorption, we are not talking about in terms of specificity. Okay, so whatever may be the gases, okay, if you allow the gas pass to the charcoal, definitely it will be absorbed. But if you take a chemical adsorption, you have to selectively, okay, pass the gases through the adsorbent. If you pass an oxygen gas, you should take only the adsorbent constant. If you are getting the hydrogen gas, you should take only the adsorbent nickel. So likewise, it will be different. The physical adsorption is what? It is not in a specific way, but the chemical adsorption, it should be in a specific manner. Why I am giving this point here? Now, next I am going to discuss about what is the difference between physical adsorption and chemical adsorption. There, this point will come as a one of the difference points. Okay, and next I am going to discuss about difference between physical adsorption and chemical adsorption. So, if you take physical adsorption and chemical adsorption, what is the difference? Okay, if you take physical and chemical, and there must be some difference. Okay, so let me take one by one. Okay, if you take physical adsorption, okay, if you take physical adsorption, it is very, very fast reaction. So, generally it is a instantaneous reaction. Instantaneous reaction. That is fast reaction. Okay. But if you take a chemical adsorption, it is a slow process. Because it is what formation? Bond formation. So, what type of reaction it is? A slow process during the bond formation. Okay. And second one, already we discussed this point. Okay. In a physical adsorption, it is not specific. It is not specific. It is not specific with the gases. But if you take a chemical adsorption, it should be specific. Okay. And specific about the adsorbate and the Students, sorry for the disturbance. Okay, shall we continue? The difference, we are in difference between physical absorption and chemical absorption. So first point, we know that it is instantaneous, and chemical absorption is a slow process. If you take a physical absorption, it is not specific, but it should be specific. Chemical absorption, it should be specific. Depends on nature of adsorbate and adsorption, that is adsorbent. Okay, so it depends upon the two factors. Okay, and if you take a third difference, okay, what happened to the effect of pressure? Okay, so if you take a physical absorption, if you increase the pressure, okay, the physical absorption increases. If you increase the pressure, the physical absorption increases. In the same way, if you go with the chemical absorption, if you increase pressure, okay, the chemical absorption also increases. Pressure, chemical absorption increases. Absorption increases. Okay. Now, how this? So, how can I know that the pressure, if it is increases, means there will be what increase of absorption. Okay. How can I understand this? You may have a question. So, what is absorption? We know. Okay. So, we know that physical absorption, whenever we are providing the adsorbent like this, okay, surface area, and those gas molecule, it is going to be adsorbed on the surface. Okay, and if you take that, suppose if I am going to adsorb like this, the gas molecule like this adsorb, it forms a layer. Okay, it forms a layer. So like whenever one layer is formed, okay, if you are supplying more number of moles, okay, because the number of moles increases means automatically the pressure also what increases. So if you increase the number of moles, we know that the physical absorption, whenever number of moles increases, it forms another layer. So one layer, it forms it has a tendency to form a multi-layer. Okay, so that only the pressure has to be what increases. Okay, but if you go with the chemical absorption, if you are providing any one of the adsorbate molecule, that is adsorbent, if you are considering, now I am going to absorb a adsorbate molecule. So we know that whenever this adsorbate molecule forms a strong bond with what adsorbent. Okay, so whenever the adsorbate molecule forms a strong bond with the adsorbent, whenever the one molecule occupied the space, okay, the space is forming a bond, no? Okay, so that space cannot be occupied by some other molecule, some other adsorbate molecule. So the chemical absorption, one day monolayer is possible. It is not forming a multi-layer. So because of that only, the pressure is what going on increases. So the pressure, when we take, the pressure will be increases. And same way, in chemical absorption also, the pressure will be what increases. But when we take the pressure, I can show a diagram like this. Okay. So whenever, if you take a physical absorption, now I am going to draw the graph between, suppose if I am taking the absorption as x by m in one axis. So x by m is nothing but it is an absorption. Okay, so x is a mass of a adsorbate, m is a mass of the adsorbent. Okay, so x is a mass of the, if you take x, mass of, okay, adsorbate. adsorbate, and M is a mass of adsorbent. Okay, mass of adsorbent. If you take a x by m value, this adsorption I'm going to take in the x-axis. Okay, and if you plot the graph between that adsorption with the pressure. Okay, if I take a pressure, we know that whenever if you increase the pressure, automatically the absorption is what going on increases. This graph is showing like this. Okay, like this. It is going on increases. So this is a graph drawn between absorption and as well as the pressure. Okay, but if you take a chemical absorption, if you draw the graph between this chemical absorption, okay, just the same graph. Okay, so if you take x by m absorption in one axis and pressure in another axis, okay, pressure in another axis, we will show some difference, because why I will explain. Okay, so we know that in chemical absorption, whenever the gas molecule is going to be absorbed, it forms a monolayer. Next, if you provide some more moles of a gas molecule, there is no surface. Okay, here if you provide more molecules, means suppose if you provide like this, all the bond is formed between that surface existing. The bond is formed between the adsorbate and the adsorbent. If you are providing some more extra moles, if you are providing, means those gas molecules does not absorb on the adsorbent. Okay, so because of that only, whenever the pressure increases, it shows a graph like this. Whenever the pressure increases, absorption increases, but next it shows some constant, because whenever the particular number of moles of gases that should be absorbed. Okay, that should be absorbed. Till the pressure increases, the absorption also what increases. Okay, till. But whenever the number of moles, if you are supplying more, the surface is not sufficient. So insufficient surface, because of that, the pressure remains constant. The pressure remains constant, even though it increases. At one point, the pressure is not existing, and the pressure is showing some constancy. Okay, so here okay, if you increase of pressure, okay, now what happened? Automatically the absorption also increases. Okay, so absorption increases, but one point absorption increases, and next when we increase our absorption, the pressure also, that absorption water remains a constant. But anyway, I'll give it in a general. So increase of pressure will increase the chemical absorption. Okay, this is a point relevant to the pressure. Okay, next we will go with the temperature. Next point. Okay, we'll go with the temperature. Okay. So whenever the temperature, we know that the temperature, if you increase the temperature, okay, the fourth point, we'll go with the fourth point. Okay, increase of temperature temperature. Now what happened to the physical absorption? Physical absorption decreases. Physical absorption decreases. Physical absorption decreases. When we increase the temperature, physical absorption, that will be what? Decreases. So if you take temperature and also the absorption, okay, I can show by using of a graph. So if you take the x by m absorption with the temperature, okay, with the temperature, it shows like this. That is the absorption, it is going on decreasing. Okay, when we increase the temperature. Now, what is the reason for this? So we know that physical absorption is due to some weak force of attraction between the absorbate and the absorbate. Okay, those weak forces you can cleave by applying of a temperature. When we apply even a minimum temperature also, okay, the force of attraction between adsorbate and the adsorbent molecules will be cleaved readily. Okay, and those adsorbate molecules will pass away from the adsorbent, and the force of attraction will be what? Readily cleaved. Okay, and the adsorbate molecule that has to be removed from the surface, so that only the absorption has decreases. Okay, this is the reason for the decreasing of a absorption, physical absorption, especially with the increasing of a temperature. Okay, and in a similar way, if you go with the chemical absorption, so chemical absorption, when we increase, okay, when we increase the temperature, okay, increase of temperature, okay, first increases, then decreases. Okay, first increases, then decreases. I can show by using of a graph like this. Okay, if you take the absorption x by m with the temperature, specifically with the chemical absorption. Okay, now the graph is shown like this. That is the absorption first, it is going on increasing, and next it will be decreasing, like your graph for the chemical reactions. Okay, if you take a chemical absorption, the graph is showing related to the chemical reaction. We know that chemical reaction in terms of activation energy. So I'll explain why and what happened to the absorption when we increase the temperature. So first it is going on increasing and then decreasing. What is the reason? Okay, so you take a adsorbate molecule. Okay, so whenever if you increase the temperature, that adsorbate molecule, so increase of temperature. Okay, if you take increase of temperature, the adsorbate molecule gains energy. Okay, adsorbate molecule gains energy. Okay, and we know that whenever the gaining of energy, okay, that is equal to activation energy, So now what is activation energy? So the energy, okay, the energy of the reacting molecule. Okay, so when we take a reacting molecule, the reacting molecule, it is possessing some amount of energy, but this energy is not sufficient to cross over the energy barrier. We know that the activation energy. Okay, so in order to cross the energy barrier, we have to supply some amount of energy. That is called additional energy. This additional energy only called activation energy. Okay, so when we supply energy to the adsorbate molecule, Okay, by increasing of a temperature only, you are supplying what energy. When we increase of that energy, you are supplying what the more energy. The reacting molecule absorbs those energy, and it is what increases the absorption. Okay, till that point of activation barrier. And after that, if you are going on supplying energy, okay, so the adsorbate molecule is getting sufficient energy. So after that, again and again, if you are providing more molecule, after that bond formation also, because we know that chemical adsorption, it is what forming of a bond. Okay, after that bond formation also, if you are supplying that energy, those adsorbate molecule, okay, it is not taking that energy. So instead, okay, because of adsorption, there will be desorption is taking place. Okay, so more energy leads to desorption. Okay, more energy leads to desorption. Now, what is desorption? The process, it is actually a process. So, process of removing the adsorbate molecule. The process of removing the adsorbate molecule. Okay, adsorbate from adsorbent. Okay, by using of a cleavation of a bond. Okay, so we know that whenever increase of temperature, first of all, the adsorption will be increases. Why means those adsorbate molecule gains energy and it is equal to the activation energy. So what is activation energy means? It is an additional energy we are going to supply a molecule to cross over that energy barrier. So like a chemical reaction, okay, here also. And same way, further increase of temperature, okay, those molecules is getting more energy. Okay, even though it is getting more energy, we know that it is not possible to absorb those extra molecule. Okay, those energy that has to be what liberated in terms of in the process called desorption. So during the desorption, the process of removing the adsorbate molecule from the adsorbent is taking. So likewise, you are giving that idea when we increase the temperature. So first adsorption is showing that increases, but after that it will be decreases. This is the reason for the falls and the rise of adsorption in increase of temperature. Okay. And next point we are going to discuss about whether it forms a. Okay. If you take a fifth point. Okay. In physical absorption, there must be multi-layer formation. Physical absorption, what? Multi-layer formation will be possible. But if you take a chemical absorption, only mono-layer possible. We know that what mono-layer means, only a single layer will be formed on the surface. We know that physical absorption is a multi-layer, but chemical absorption it is a mono-layer formation. Okay, and if you take the next point, heat of adsorption. Here, heat of adsorption is low. Heat of adsorption is low. Okay, is low. So that is related to 40 kilojoule per mole. But when we take a chemical adsorption, the heat of adsorption is high. We know already that value. So 400 kilojoule per mole, the heat that has to be liberated during chemical adsorption. Okay. And here, next point we are going to discuss about in that is physical adsorption. There is no transfer of an electron because we are talking about in terms of force of attraction. Okay, so it is a force that will be help us to bind the adsorbent with the adsorbent. So there is no transfer of electrons in physical adsorption. But if you take a chemical adsorption, there will be transfer of electrons. There will be transfer of electron. Why means? Because it is a bond formation. So the transfer of electrons, it should be taking place. Okay. And if you go the next point, okay, so the physical absorption, it is not concerning with the sites. Okay, it occurs at all sites. It occurs at what? All sites. But if you take a chemical absorption, it occurs only in the active centers. Where it is occurs only in the active centers. Okay, active centers only we are getting this. Okay, and same way, next point, if you are going that in physical absorption, there is no insignificant. Okay, with the activated complex. Insignificant with the activated complex. We are not considering about the activated complex, but here we are considering about the activated complex during the chemical bond, that is chemical absorption. So activated complex is considered here. Activated complex considered. So those points should be very, very clear. Okay, and this should be considered as a difference point between the physical absorption and the chemical absorption. So far we discussed about all those points. Okay, difference today we discussed about only what is physical absorption, chemical absorption. Okay, and what are the types of absorption. Okay, now just okay, now students, can you hear me? Students? Yes, okay.
Yes,
Have any doubt in that physical absorption and chemical absorption difference? What is that? And what is called absorption? Do you understand the points? Say yes.
yes, ma'am.
The S is coming very slowly, so we'll take that it is somewhat doubt. Friends?
No, ma'am.
No. Okay. So is it possible to follow?
Yes, ma'am.
Okay. Now types. What are the two types of absorption?
Physical absorption, chemical absorption.
Okay. Physical absorption is the force will be acting between adsorbate and the adsorbent. But in chemical absorption, what is acting in between these two, adsorbent and adsorbate? What could be formed? Can you answer me?
Bond.
Okay.
Strong bond.
Strong bond.
Okay. So any doubt in that area?
No, ma'am.
No. Okay. Shall we close the class? We take 10 minutes break. 10:20 shop. The next class will be started. Okay. And get ready for that.
Yes, ma'am.